Hi class, welcome to lesson 52, the first lesson in our kinetics and equilibrium unit. Today, we are going to determine the effect of collisions on reaction rate and determine the factors that affect reaction rate. So kinetics is the study of the rate or speed of a chemical reaction. A chemical reaction involves the breaking and the remaking of bonds. In order to break a bond, you must add in energy. So here in this chemical reaction, when we want to make a product, carbon dioxide, we'll have to break the bond in the oxygen and then reform bonds to make carbon dioxide. The enthalpy or heat or delta H of the reaction will be positive if you have to add more energy to break the bond than you get out for making the bonds, or the delta H will be negative if you release more energy from making a bond than it cost for breaking a bond. We can find delta H values for many chemical reactions on reference table I. Different reactions happen at different rates. Like spilling bleach on your shirt will leave marks very quickly. Fireworks is a nearly instantaneous reaction, but the rusting of metal takes a very long time. And the erosion of rock takes even longer time. Alka-Seltzer reacting in water is pretty quick, but the decomposition of plastic is a very slow process. As we study kinetics, or the speed of chemical reactions, we'll note that chemical reactions occur when reactant particles collide. They must collide with the sufficient amount of energy and a proper orientation. If they do not meet these two criteria, even when mixed together, no reaction will occur. So let's look at an example of these conditions with a reaction for the synthesis of hydrogen iodide. In the first setup, we have hydrogen and iodine colliding, but they are not in the proper orientation, so no reaction will occur. The reactant particles have to be stacked differently in order to form the products. In the second example, the reactants are stacked in a proper orientation or arrangement, but if they collide with insufficient energy, again, no reaction will occur. But in the final example, what we have is we have our particles in the proper orientation, and if they collide with sufficient energy, then the reactant particles can break bonds and the product particles can form new ones, so a reaction will occur. There are 6 major factors that affect the rate or speed of a chemical reaction. These 6 factors that we are going to look at are the nature of the reactants, concentration, pressure, temperature, surface area, and catalysts. Whenever we go and we increase the rate of a chemical reaction, we are increasing the number of effective collisions. Can you summarize how changing the number of effective collisions will change the rate of a reaction? Now let's see how the type of reactant impacts the rate. Ionic substances in aqueous solutions will react faster than covalent substances. This is because when you place an ionic substance like silver nitrate into water, it will dissociate into ions that want to make new bonds, so they'll be able to react faster than covalent compounds that do not dissociate into water, so they'll have to break bonds before they can make new bonds. Between these two compounds, can you determine what type of bonds are present? Which of these is going to have a faster reaction? Increasing the concentration of reactant particles increases the reaction rate. That is because when you have fewer particles, you will have fewer effective collisions. But when you have more particles, like on the image to the right, you can have more effective collisions, thus a faster reaction rate. Increasing temperature always increases all reaction rates. Increasing temperature is a double whammy. When the particles are moving faster, they are going to collide more often. And when the particles are moving faster, they are going to collide with a greater force, meaning they have sufficient energy for a successful reaction. You can see the particles that are at low temperature are moving slowly and not colliding as often or with low energy, but the high temperature particles collide often with great energy. Here is a reaction that tests the effect of temperature on reaction rate. Here we have 3 glow sticks. One is placed in hot water, one in warm water, and one in cold. Notice that the glow stick placed in hot water glows brighter. It has a faster reaction rate because its particles are colliding more often with more energy. Increasing the pressure of the gas is similar to increasing the concentration of a reactant. Increasing pressure of a gas increases the reaction rate because it causes more effective collisions. To increase the rate, we always increase the number of effective collisions. So as we increase pressure, you can see that the particles are closer together, and they're going to collide with one another more often. The next condition that can increase the reaction rate is when we increase the surface area. Increasing surface area increases reaction rate because you increase the amount of material exposed to react. So again, we have more effective collisions. Recall that when we decrease particle size, we are increasing the surface area. So here in this image, you can see that when we have a large size, very few of the particles can collide with the blue. But when we decrease the particle size, we open up and we allow more particles to collide with the smaller blue particles, thus increasing our reaction rate. Let's look at the burning of steel. Steel is usually thought to be a dense metal that does not burn, but here, steel wool has a high surface area, so it very quickly burns. The final condition we'll look at that speeds up a chemical reaction is the addition of a catalyst. Catalysts are substances that are added to reactions that do not change the beginning or the end point. They just make the reaction happen faster. Catalysts were very important in living environment as they are essential for the reactions of life. Notice that catalysts change the pathway of the reaction, but they do not change the beginning or the end, the reactants or the products that we end up with. Here is one more example of how a catalyst can be applied to a reaction. Notice that the general shape of the curve does not change. The reactants and products are the same, but the pathway in which the reactions are converted to products is different and will require less energy. It is important to realize that the heat released or absorbed in a chemical reaction when a catalyst is added is never changed. So the delta H value on table I is the same. This is the end of the first lesson of your Kinetics and Equilibrium unit. Make sure that you understand that we increase the rate or speed of a reaction by increasing the number of effective collisions. Write down any questions you have and bring them to class. See you soon.